suspension arm. Notice they have a blue model that we would call what? The design space. The middle model, which is kind of this rough, crude, tessellated thing, is what? It's the optimized, discrete model. And then you have to somehow take that representation and transform it back into CAD so that you can do regular engineering. You can do your manufacturing, you can do finite element modeling of the actual part being manufactured. So the process is really one of kind of doing a conceptual design space model, letting the software run its course, giving you a tessellated model, taking the tessellated model and transforming that back into a CAD model. In this example that they talk about it reducing the mass by 37%, and they talk about it reducing the actual time, the design time, by more than 30%. The last example that I have is this case study that's both a aerospace case study with a golf club manufacturer's case study. On the top one, what they're doing is redesigning the hinge of the main door in the airplane. If you look at the little chart off to the right, you'll notice that the design time was reduced by 75%. There was a mass savings of 20%. 20% mass savings in aerospace is gigantic. Okay. In the golf club area, they had better performance, was up 10%. Lower mass was down by whatever that is, 17%. And the more durable, it's blurred out, you can barely read it. The more durable, which means that this can take more hits and still keep performing, was actually improved also. Okay. This, again, is uploaded to TCC. There's a couple of links in there that I think are worth doing. If you go to this page and click on the link, it will take you to the HyperWorks page. It will require that you set up either a guest account or set up a regular account. It doesn't hurt to set up a regular account. When you go into this thing, invalid email, it requires the entire email. I should have remembered that. It takes a minute and it actually loads up a lecture that takes about takes roughly an hour to go through, but it goes through and sets up, this is the design space, this is the non-design space, this is how you put on, and there's a person talking you through literally every click. And so it's almost there. We'll wait for another second or two. And so if you have been struggling kind of doing the tutorials without somebody coaching you and talking to you and everything else, and you've been a little frustrated, both of these tutorials, you can actually have somebody talk to you.
Yes, push. Is your volume up?
No. Go next to the top. Get to push that button.
What's that?
It's a tutorial. It's a virtual tutorial. So you have to press play. So select the. Yeah.
It's there, but it's pretty quiet,
It's coming pretty quiet out of your computer.
and it's coming quiet out of my computer. So if we do this,
make sure object struct is selected.
still pretty quiet. Anyway, the point being is they literally coach you through how to walk your way through this. I don't know why it's gone really quiet again. But so there's this presentation, and there's also this link that'll take you to two different examples where it'll just talk you through, hopefully get you well prepared for the work that you're doing this week and the work that you'll be doing on your car project. So today's lecture was supposed to also continue a discussion of topology optimization. I decided to suspend that lecture for at least a day or two. And what we're going to spend time talking about today is modeling our RC platform, or eating an elephant. Okay. I've gotten a number of emails from remote students. I've had a few of you come into my office and try and discuss how you should approach this activity, what you should be doing. So I decided that instead of just plowing on further down the road and giving you more information, we ought to kind of back up and maybe look at this thing again. Okay. How much parametrics? That's the question. How much parametrics? Okay. What should be parametric? What should be fixed? That should be going through your mind. Who gets to decide? Who does get to decide? Dr. Jensen, the TAs? Your team gets to decide. Okay? Your team should be sitting down and saying, do we want this to be parametric? Do we want this to be parametric? Does this need to be parametric? Does this need to be parametric? And so hopefully this presentation is going to address some of the questions, some of the confusion that you have back in the back of your mind. How large? How small? What are the limits on the size? Should the variation be infinite or should it be discrete? Well, the first question I would ask is, what size is your car that you're working on? Is it a 1/20th scale, a 1/18th scale, a 1/15th scale? What is its actual size? Whatever that size is, you need to decide, am I going to make this a full-size vehicle off of taking dimensions off of this little car? Or am I going to just scale it down if it's a 1/15th scale? Am I going to go down to a 1/20th? I mean, there's lots of little RC cars that you can buy at Christmas time that are 1/20th scale.